On task. Okay, so this is November 20th. We are going over questions related to curve sketching with Trig. We're starting with number 33 in section 3.1, which says that f of x equals the cosine of pi x on the interval from 0 to 1 over 6. And we're asked for the absolute extrema. Absolute extrema on a closed interval, you find your critical numbers and then you test the critical numbers and the endpoints by plugging them into the original function. So, first thing we have to do is find f prime. So what is the derivative of cosine? Negative sine. And so I'm going to put a little tiny bit of space because it's negative sine pi x times the derivative of pi x, which is pi. So I'm going to put the pi in front. So we have the derivative is negative pi sine pi x. So this is never undefined, but it can be 0. Now we haven't really talked about how to solve an equation when it's not just x, right? We all know how to solve sine x equals 0 because x is 0 and pi and 2 pi and all the multiples. But how do we know when pi x is 0? Well, the way that you solve it is you just set whatever the argument is. It wouldn't matter if it was 3 pi x over 26. You set whatever is there equal to all the values you want. So we would want whatever's here to equal 0, pi, 2 pi, and so forth. It's not there's no negatives in there, so we don't have to do negatives. So anyway, so if this whole quantity equals 0, then it would be true, right? If the whole quantity of pi x equaled pi, then we'd have sine pi, which is also 0. And then how do you solve for x? You just divide by pi. So 0, 1, 2, dot, dot, dot. Now on this interval, the only number that's there is 0, which is an endpoint anyway. So the critical numbers in this particular problem are meaningless, they're moot because we don't need them to test because they're not in the interval. So we just test the endpoints. So f of 0 is cosine 0. Anyone know what the cosine of 0 is? 1. It's 1. F of 1, 6 is the cosine of pi over 6. Anyone know what that is?
Root
3 over 2. Okay. Which of these is bigger, 1 or root 3 over 2?
Root 3 over 2. No, 1.
No, 1.
1. 1.
1. 1. And if you think about it, it's a cosine function. The highest it's going to be is 1, right? So anything else is going to be lower. So this is our max, and this is our min.
Took the physics test today, guys.
And do we want to plug them back?
First step, first two.
These are y values. That's how we found
So
them.
it'd be 0, 1, and then 1, 6.
Well, when we write absolute extrema though, when we say what's the max, we only list the y value, right? Not the x value. We only write absolute extrema as an ordered pair if it's specifically asked. Otherwise, if they say what's the maximum value of the function, they only want the y value.
And for relative, it's always ordered.
Correct. For relative extrema, it's ordered pairs. Okay, so now, whoop. Yes? Oh, these? Okay, well, I'm solving the equation sine pi x equals 0, right? If I have sine whatever, think of it as, sine happy face equals 0, whatever's in there, right? Then if I plug in, if whatever is there is 0, sine of 0 is 0, right? If it was pi, sine of pi is 0, right? Sine is 0 at all the multiples of pi, right? So whatever is in here, we want that to equal all the multiples of pi. Because that's where sine equals 0, right? And then, so then we have to actually find x values. We've got to divide the pi out. And what happens, if you think about it, guys, if you plug these numbers in, so if x is 1, I get sine of pi, right? And if x is 2, I get sine of 2 pi. Does that make sense? Okay. All right. So now we're in the next section, 21, in section 3.2. 21 is a Rolle's theorem question, and it said f of x equals 6x over pi, so I'm going to write 6 over pi times x, minus 4 sine squared x on the interval from 0 to pi over 6. Now, this function on its own, is it ever undefined? No. Sine and cosine are always continuous, right? They're always continuous. If you think about the graph, I'm off the camera right now, but if you think about the graph, it's that continuous oscillating curve. Excuse me. And of course, this is just x, which is continuous. So this is always continuous. So first thing we have to check for rolls is that f of x is continuous on the closed interval. Check. Make sure you really do check, because there might not, but there might be a problem on your quiz where the function's not continuous, right?
Oh, thank you.
So if they asked you for, secant, then you'd have to check to see is cosine equal to 0 anywhere in the interval, and if it is, then the function's discontinuous and the theorem doesn't apply. So make sure you check that the function is continuous on the interval. So it might be, it might not. Now, we need to check for differentiable. We know that sine is differentiable as well, but let's go ahead and find f prime. Just to make sure. So we get 6 over pi, and then here, remember to differentiate sine squared. Think of it as sine squared like that, right? So we get negative 8 sine x to the first times the derivative sine, which is cosine. To find the critical numbers, first of all, let's just take a look at this. This is always continuous, never undefined, never undefined. So that means f is differentiable on the open interval 0 to pi 6, check. The third check that we have to do is check to see if our endpoints are the same. F of 0 is 0 minus 0, so it's 0. F of pi over 6, we get 6 over pi times pi over 6, so you get 1 minus, the sine of pi over 6 is a half, squared is a fourth, times negative 4 is 1, so you get 1 minus 1, which is 0. That's why they did it like that. So f of 0 equals f of pi 6, check. Therefore, Rolle's applies. Okay? Now, once you've got that it applies, you have to set your derivative, this thing, equal to 0. There's no way to do that without a calculator. And you can try. Did anyone try?
No, I saw that it said do C with the calculator.
How would you do it with your calculator though?
How would you do this with your calculator? First, yeah, with the solving, it won't work, but I would put into y equals, graph, and find the zeros.
Okay.
That's what I do.
You couldn't do sine inverse and then cosine inverse. You couldn't do that. Like if you
Oh, that would be tricky.
Because I equated 0 and then I brought the 6 pi minus 8. Like 6 pi to the other side divided by minus 8 and then
I don't know. I'd have to think about that a minute to see if that would work. I personally would just throw the whole thing into y equals and find the zeros.
okay.
That's what I would do.
Not like directions.
Okay. Alright, so that's that one. So, if this were a problem on your quiz tomorrow, this would be one that you would be able to solve by hand. There's nothing that crazy. There's nothing wet. There's no calculator required problems on your quiz tomorrow.
Ms. Trig,
Yes?
will you please send Noah another to the weight room?
To the weight room? Sure.
Emergency squat, go.
This is great.
Yeah.
So if it says like tan x times or cosecant x times secant x or something, like if the expressions are multiplied together, do you always need a calculator?
Well, if it equals 0, then it's a piece of cake. You don't need a calculator. But if it equals 5, then yeah, you would need a calculator. Right, if two things multiply and equal 0, they just said each of them equal to 0, right?
Yeah.
Right, but if they equal some other number, then if you can't factor it, you have to use a calculator. Yes?
On like an MBT problem, if everything works except like alright, so like the domain is like non-inclusive and everything works, but then C comes out to be one of the endpoints, then doesn't
That
work.
would not be a correct mean value theorem then. Something would have not worked. There has to be a C inside the interval or the theorem didn't apply.
Okay.
Yeah. Okay, moving on. So now we're on 45 on page 186. So 45 says f of x plus u equals sine squared plus sine x. Now that we're doing these kinds of problems, these are really good ones that you might want to actually kind of take notes on. So here we go. All we're doing for this is finding increasing, decreasing, and relative extreme, right? Okay, so first thing we got to do is find f prime. So this is, again, that chain rule. So it's 2 sine x times cosine x plus cosine x. So now, in order to find the zeros, I'm going to factor out a cosine. So we have 2 sine x plus 1. So I get cosine equals 0, or sine equals -1/2. And we've got to have an interval. Oh yeah, this is on the interval 0 to 2 pi, not including the inputs. Okay, so on that interval, where is cosine 0?
Pi over 2 and 3 pi over.
Beautiful. Pi halves, 3 pi halves. Okay, sine, let's just say +1/2 right now. Where is sine +1/2?
7 pi over. Oh, it's positive.
Pi over 6, right? So we want negative, so we want the pi 6 angles in which two quadrants?
3 and 4.
3 and 4, the ones down below the x-axis, 3rd and 4th. So we want 7 pi 6ths and 11 pi 6ths. Okay, so there's our critical numbers. We make a sine line from 0 to 2 pi. Make sure you put the numbers in the right order. Believe it or not, what's the lowest of all 4 of these numbers?
Pi over 2.
Pi halves. Which one comes next? 7 pi 6. Bless you. Then what? 3 pi halves. And finally, 11 pi over 6. So this is our f prime. And so, bless you. So if we plug in from 0 to pi halves, cosine is always positive there, right? So just worrying about this, if I pick any angle at all, I'm going to get a positive, right? Plus 1. So we have a positive times a positive, we are positive. From pi halves to 7 pi over 6, what's the best angle to pick? Pi. Always pick the one that's 0 or 1, right? So we pick pi. Cosine, you know what cosine pi is? -1, right? So I have a negative, sine of pi is 0, so plus 1 is positive. So I have a negative times a positive, we're negative. Between 7 pi over 6 and 3 pi halves, you can pick the pi fourths or the pi thirds angle in the 3rd quadrant. So if you want to do 4 pi thirds, right? If you want to do 5 pi fourths, whichever one you want to do. So let's do 4 pi thirds. 4 pi thirds, cosine would be -1/2, so we have a negative, right? The sine of 4 pi thirds would be -√3/2, so we get a -√3 plus 1. -√3 plus 1 is going to be negative, because √3 is bigger than 1. So we have a negative times a negative, we're positive. All right, 3 pi halves to 11 pi 6. I'm going to do the pi thirds in the 4th quadrant, so we're going to do 5 pi thirds. Cosine's positive in the 4th quadrant. So sine of 5 pi thirds is again -√3/2, so we get -√3 plus 1, which is negative. Positive times a negative, we're negative. And finally, between 11 pi 6 and 2 pi, this guy's positive. We gotta figure out this one. This is what we did yesterday. Sine is 0 here and -1 here, and it's -1/2 at 11 pi over 6. So between here and here, it's gotta be between 0 and -1/2. So pick like -1/4, right? So if I do -1/4, I get -1/2 plus 1, which is positive, 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 positive. That was a lot of work. So just FYI, on your quiz tomorrow, there's only 2 critical numbers, so it's not quite so comprehensive. All right, so anyway, so we have F is increasing on 0 to pi halves, union 7 pi 6 to 3 pi halves, union 11 pi 6 to 2 pi, because F prime is positive. F is decreasing on pi halves to 7 pi 6 and 3 pi halves to 11 pi 6, because F prime is negative. And then we have relative max, rel max at pi halves, comma something, and 3 pi halves, because F prime changes from positive to negative. And we have rel mins at 7 pi 6 and 11 pi 6. Because F prime changes from negative to positive. Where do I get the y values for the relative extrema? Original function, yay! Okay, so if we plug,
You spent more than 15 minutes on the homework.
I know, this is a big problem. Okay, so if we plug pi halves in, thank goodness, sine of pi halves is 1, right? These are good things to know. Okay, sine of pi halves is 1. 1 plus 1 is 2. So we have pi halves 2. Sine of 3 pi halves is -1, but -1 squared is 1. So we get 1 plus -1, which is 0. This would be a fun graph. 7 pi over 6, the sine of pi over 6 is 1/2, so the sine of 7 pi over 6 is -1/2. So we get -1/2 squared, which is 1/4, minus 1/2, so -1/4. And then same thing, 11 pi over 6, you get -1/2, so you get -1/4. Kind of curious how this one looks. Later, if there's time, we will. But the one that the next problem we're about to do is gonna put it all together, or maybe not. No, we're about to do a point of inflection one first. And then 42 is the best one. So I'm not gonna spend more than, don't let me spend more than 3 minutes on 23.
I got my timer out.
You got your timer?
Also,
Alright,
Okay,
whatever you are.
I'm not ready.
1 minus 2. She's not ready.
Okay. Okay, so this is now section 3-4, number 23. We're finding concavity and points of inflection for f of x equals secant of x minus pi halves from 0 to 4 pi. That's a big interval. Okay, so we find f prime, which is of course secant x minus pi halves tangent. Do you know there's actually a much easier way to do this?
Oh?
Because you can convert secant of x minus pi halves to just cosecant x, right? Aren't they just shifted? It's either positive or negative cosecant. I have to think about it for a minute. But doesn't that make sense? It'd be like a really fast, easy derivative. but do you think, okay, I don't want to get too deep. Okay, times the root of the argument, which is 1. Alright, moving on. F double prime, let's just keep it like this and we'll just move right along. So, product rule, derivative secant is secant tangent.
I believe in you, Ms. Price.
Times tangent.
She's using the skinny marker today.
Ooh,
Plus,
that's different.
I gotta take time to erase.
Dun dun dun. Oh, is the timer?
Got 1
Oh,
minute 35.
this is
1
I'll
minute
never
mark.
make it.
1
Okay.
minute mark.
No, you started the timer early. She didn't start
Secant.
the thing again, so she got
Alliterate on the
1:30.
problem, bro.
Times the derivative tangent, which is secant squared. Okay, so here's what we have. If we factor out a secant, we get times tan squared plus secant squared. Tangent squared, if you do the Pythagorean identity, tangent squared is secant squared minus 1, right? Am I doing that right? So, because we got to get it all to one function or we won't be able to solve it. So we get 2 secant squared minus 1. All right. This, if you solve this, you get secant squared of whatever equals 1/2. So secant would be plus or minus the square root of 1 over, the square root of 1/2, which is 1 over root 2. That never happens, right? Cosine can be 1 over root 2. Secant can never be 1 over root 2, right? So, so this has no solution. There are no critical numbers from this guy. This one, if you set secant equal to 0, secant is never 0, but it can be undefined. Okay, that's fine. I'll be okay. So anyway, so it can be undefined. So it's undefined wherever cosine is 0. So what you get is x minus pi halves equals, well, cosine is 0 at pi halves, 3 pi halves, 5 pi halves, 7 pi halves, dot, dot, dot. You add the pi halves and you get pi, 2 pi, 3 pi, and then 4 pi, which is the endpoint. If you make a sine line from 0 to 4 pi, pi, 2 pi, 3 pi, we have, okay, I'm going to pick pi halves. If I pick pi halves, I get secant of 0, which is 1. So that's positive. And here I get 2 minus 1, which is positive. And I'm just going to tell you right now, for sake of time, it goes like that. We're concave up, down, down. And actually the graphs literally kind of look like that, right? So, anyway. This problem is about 1,000 times easier if you convert the secant to a cosecant. So, anyway. All right, without writing any answers, I'm moving on because 42 is the one we want to focus on today. So, take good notes on 42 because we're going to work it start to finish, although I'm not going to write because statements right now just for time's sake.
Got like 7 minutes before 15.
Okay, thank you. Okay, here we go.
Stop working on the homework. Problems before.
All right, guys, 42. I'm in the wrong section. Here we go. So, 42, y equals 2 times x minus 2 plus cotangent x on the interval from 0 to pi. This marker's dying. Okay. So here we go. Y prime. This is 2. Derivative of cotangent x is negative cosecant squared x, right? So you get cosecant squared x equals 2. So cosecant is plus or minus root 2. Or you can think of sine as plus or minus 1 over root 2, right? So these are all the pi fourths angles. So we get x is pi fourths or 3 pi fourths in that interval. And make sure you cut off your sine line at the endpoints. So this is our y prime. Here if I pick pi over 6, the sine of pi over 6 is a half. So the cosecant is 2, squared is 4, 2 minus 4 is negative. Here if I pick pi over 2, sine of pi over 2 is 1, so the cosecant is 1, 2 minus 1 is positive. Here if I pick 5 pi over 6, sine of 5 pi over 6 is a half, cosecant is 2, squared is 4, 2 minus 4 is negative. We're decreasing, increasing, decreasing, relative min, relative max. Y double prime. This derivative is 0. Okay, so we're going to use chain rule, minus 2 times cosecant x to the first times the derivative of cosecant, which is negative cosecant cotangent.
Ooh.
So we end up with positive 2 cosecant squared x cotangent x. This guy is never 0, but it is undefined when sine equals 0. So we get a critical number at 0 and pi, which are the endpoints, right? This guy is undefined also when sine is 0, and it's 0 when cosine is 0. So you get pi halves. So if we make a sine line for y double prime, the only critical number is pi halves. From 0 to pi halves, cosecant anything squared is always positive. So we just have to check the signs of cotan. Cotangent from 0 to pi halves is positive. From pi halves to pi, it's negative. We are concave up, concave down, and we have a point of inflection at pi halves. All right. If we were to make one great big sine line to graph, so our critical numbers are pi fourths, pi halves, 3 pi fourths, and pi. We are decreasing, increasing, increasing, decreasing. We're concave up, up, down, down. So the shape of our graph okay, so the shape of our graph is that way, that way, that way, and that way. We need some points to plot. So to get the points to plot, we have, hi, real quick.
It goes to Christian.
Oh, okay. Christian, I'll give this to you in a minute. Okay. So to get the points to plot, you would find the actual relative min and max and point of inflection. So very quickly, we're plugging into the original function. So let's do 2x minus 4. It's just easier for me to think. So 2 times pi fourths is pi halves minus 4. Cotan of pi fourths is 1. So we get 2 pi halves minus 4 plus 1, or pi halves minus 3. At 3 pi fourths, we get 3 pi halves minus 4 minus 1, so 3 pi halves minus 5. And then at pi halves, we get pi minus 4 plus 0. Make sure it's not undefined, and it's not. So we get just pi minus 4. At 0, the first thing you want to check, this is a cotangent function. Cotangent has asymptotes, right? It has asymptotes whenever the sine is 0. And the sine is 0 at 0 and pi. So the endpoints of our interval, it's a tiny bit past 3, will be asymptotes. Pi is around 3. So this is around 3/4, -1.5. roughly. 3/2 minus 3. So you go to 3/4, -1.5, and you put a point. 9/4, which is a little over 2, and then this would be 4.5 minus 5. So 9/4, -1/2, so somewhere around, let's see, 9/4, did I do that right? Yeah. 9/4, -1/2, so somewhere around here. 3/2, 1.5, -1. So 1.5, -1. There's our 3 points. Let's connect the dots. From 0 to pi/4 we have this shape, so we're going to go follow our asymptote with that shape. From pi/4 to pi/2 we have this shape, so we connect whoop, pi/2 to 3 pi/4, whoop, and then 3 pi/4 to pi, whoop, and we get that. And we finished by quarter after. All right, so